Okay, so now let's continue our discussion, getting a little deeper into what Java supports from a broad perspective, and then we'll do a deeper dive on the atomic operations next. So Java provides a bunch of atomic operations both at the programming language level and as far as the class libraries that it supports. So let's start off by talking about some of the different variations of this. One approach is called volatile variables. And the volatile variables are something that are used to, volatile variables are used to ensure that a variable is read from and written to main memory and not cached. And this is a really low-level feature built into the Java programming language, and we can use it for some very limited things. It's very efficient, but very limited. So let's take a look at a simple example. One is to share a field between two threads. So here's a little program. You can read more about this program at this site. Hey, look at that. Yay, now you don't have to squint. So this program, believe it or not, alternates printing ping and pong between two threads, T1 and T2. And if you take a look, you can see how it's going to do it. It's going to do it by using a volatile variable. So if you take a look here, you can see that we define the variable field val as volatile, which is what's known as a type qualifier. I'll talk more about that in a second. And if you don't make val volatile, if you omit the volatile keyword, then this program won't work properly because the visibility of val from one thread to the next will not propagate atomically or in a timely way. So let's take a look and see how this all works. So first and foremost, when you define a variable as being volatile, what it means is that reads and writes to that field always go directly to main memory and bypass any local caches. If you omit volatile, then things can be cached for reading and writing. But when you say it's volatile, then it's got to be read and written to atomically from main memory. So here are the fields. What we're going to do is we're going to have thread T2, and it's going to start up. And you can see what thread T2 does is it goes into a loop, and it's going to loop while starting with the current val, which starts at 0, up to some max, which might be 10 or whatever. And every time it goes through, if LV doesn't equal val, then it's going to go ahead and print pong, and then it's going to set LV equal to val. So that's what it's going to do. And the reads of val in both of those locations are done atomically, so they go and grab the main memory. Here is the other thread. This is the writer thread, and this is the thread that's going to be doing ping, or the changer thread. So this also loops while LV equal val, val less than max. Same looping conditions. And every time through, we're going to increment LV by 1 and pre-increment it so we store that value into val. So it's going to start off by val starts at 0. We increment LV. That is not ever going to be subject to race conditions because that's a local variable within the scope of the method. So we're going to set this to 1, so that'll atomically write it to 1 the first time in. Then it'll say print LV, so it's going to print the value 1. Then it's going to go ahead and sleep, and then it'll loop back around again. And what'll happen in that case is that the other thread at that point is going to get a chance to run, and it's going to do its thing. And so these reads and writes are done in such a way that they're done atomically. And as a consequence, the program will see the result. So if we didn't make val volatile, then the other thread wouldn't see the right value. There's also a bunch of low-level operations that are defined in the Java unsafe class. I'm going to talk a bit about these in this set of slides, and then we'll talk about how the Java atomic classes build on them. These operations, the operations defined in the, quote, unsafe class, as the name may suggest, are designed only for use with the Java class library, not by normal application programs that we might write. So you actually cannot access these fields directly in Java, typically. The most useful of the various methods are the compare and swap methods. There's the compare and swap int, compare and swap long, and so on and so forth. And they're the ones that are the basis for all the other stuff that's done in Java. And we're going to talk a lot about compare and swap because that's at the heart of everything. All the concurrency mechanisms, for the predominant number of concurrency mechanisms at their core, use compare and swap for some things. Not all things, but some things. So let's kind of talk about what compare and swap does. So what compare and swap does, if you look at it from a high level, it atomically compares the contents of memory with a given value and modifies the contents to a new given value if and only if they match. Now, what the heck is that about? So we'll kind of break it down and look at it in more detail. And I'll do that in a minute. Given compare and swap, something that works in the way that compare and swap is designed, you can then implement other so-called lock-free or non-blocking algorithms based on compare and swap. And the key thing to remember about compare and swap is it never blocks. It never goes to sleep. It just checks. Like a spin lock. So here's an example of a spin lock using these mechanisms. And we'll again kind of talk about this in more detail. But in a nutshell, at a high level, lock and unlock use this compare and swap operation. Actually, lock uses compare and swap to implement a simple spin lock. And we'll talk more about these things in detail in just a second. Okay, so that's the high-level view. There's a primitive that's built into the hardware called compare and swap, int, compare and swap long, whatever. And then other things are built on top of that. There's a really nice tutorial by Doug Lee that talks about how things are developed in Java, and he talks about the use of these compare and swap operations. So volatile variables are there for you to use. The unsafe class really isn't intended for users. The good news is for Java developers, they've encapsulated the key features of the unsafe class in a set of so-called atomic classes, and there's a whole boatload of them. They're all more or less the same. Internally, they use the Java unsafe class because they're part of the Java class library, so they can do all these things that mere mortals aren't intended to do, to implement lock-free methods, such as atomic long, atomic Boolean, atomic reference, all the good stuff that we're using in this class for various purposes. And we'll talk about those in a second.